Okay, today we're going to review inequalities versus linear equations. And for a linear equality, you notice that the solutions are not just on the line. For example, here in a less than or equal to inequality, but it actually encompasses the whole shaded region. So to review about linear inequalities, let's take a look at the slope. What is the slope of this function? The slope of the function is 3/2. That is the coefficient that is in front of the x. That's my slope right here. So we pick on your assignment 3/2 over here. On the next question, what is the y-intercept of the line 3/2 x plus 3? It is going to be 3. That is my y-intercept of this function. Okay, so now let's input the slope of the function below. Then watch to see if your slope creates an equation that matches the graph to the left. So I'm going to go ahead and pause. Record. Okay, so we're going to, before we input the slope, we have to find two good points. Damien said 0, 2. So you click on the graph, there it is, 0, 2. And you notice that there's another point that's all of a sudden highlighted. This is what they call the x-intercept, because we can clearly see that it crosses the x-axis at this point. So 4, 0. That's 2 points that we have that we can create a slope. Can anyone tell me what is the slope of this function now with these 2 points? Remember, our slope is equal to the rise over the run in basic terms. Or in this case, they call it the change in y over the change in x. That means I have to subtract 2 y points from each other divided by the subtraction of 2 x points. So here is my y1, here is my x1, this is my y2, this is my x2. Now there's 2 ways of doing this. When you visually see something like this, I have to say, okay, I always read the graph from left to right. So this is my left point. I'm trying to move to my right point over here. So that means I have to move down how many units? Can anyone tell me how many units I have to move down? No, not 3. Moving down 2. Thank you. I had to move down 2 units. So that's why I do -2, because I went from 2 to 0. So I have to subtract 2. Then I move to the right. How many units? How many units did I move to the right, guys? 4. Very good. Thank you, Jerry. Whoops. Not this guy. Hold on. Sorry. Get a little messy here. X1, Y1. Oh, sorry, 2. So I have to move across 4. So if I actually do the math to this, I subtract 2 from 0 on the top, 0 minus 2, divided by 4 minus 0. So what do I get? I get -2 over 4. Hey, look, -2 over 4. So there's 2 ways of showing it. And the graph is a great way of showing how to find the slope. So what I can do is reduce this to -1/2. That is my actual slope, because the top and the bottom are divisible by 2. So here, let's see, let me go ahead and pause for a moment. Okay, so now we have to draw the slope. So there's a keypad function over here. I click on this, and I'm going to type in -1/2 as my slope. So -1 divided by 2 equals, this is what it equals to, and there it is. It actually drew for me the slope of that graph of the function. And it's correct. Okay, I'm going to go ahead and clear the drawings and move on. So that's what we have. So the next one, which equation below represents the graph shown? I'm going to pause for a moment. Number one, let's figure out the easiest thing. Where does it cross the y-axis? Then number two, let's find the slope. So can anyone tell me, where does it cross the y-axis at, guys? 0,5, correct. So it crosses it right here at 0,5. See how I can click on it? 0,5, there it is. So guess what? 1, 2, 3, I can cross out, at least I can scratch out one of these. I can scratch out this one too. Okay, so now I'm down to just 3, right? Okay, now the next one, we know that it equals to 5. Let's find the slope, m. Thank you, Mia. That's correct too. That is the y-intercept. Let's find m. So, guess what? Look how they highlighted another gray point right there again. So they gave me a point right there. So I can actually move to that point. So let's see what it is. My slope is going to be 0 minus 5 divided by 2.5 minus 0. So this is my x1, x2, I'm sorry, x2, y2. Because remember again, we read graphs from left to right. So this is the left point. We're coming down to the right point. So I'm subtracting y2 from y1 and then x2 from x1. So what do we get? -5 divided by 2.5. Can anyone tell me what is that going to simplify to? What is -5 divided by 2.5? Close. -5 divided by 2.5. Right here on the board.
Oh, by 2.5?
Yeah.
Then -2.5.
So are you subtracting or are you dividing?
Right.
-5 divided by 2.5. Guys, you just take out a calculator and just do that. -5 divided by 2.5. What do you get? Thank you. -2. So that's my slope. So on my preview, that's what this is. So I'm going to go ahead and clear my drawings for a moment. And it says explain your thinking. So here you type out what you think is your method of solving this. So number one, what did we do? We found the y-intercept. Number two, we found the slope, right? Okay. So here's your inequality. Y is greater than x over 2 minus 2. You see that it's shaded above. All the points that make this inequality true lie within the shaded region. Note that the point T is not a solution. Explain why. So this is your own words explaining why is this point not a solution. And it's very simple. Can anyone tell me just simply why is this point not a solution? It's not exactly, that's it. It's not in the shaded region. That's plain and simple. That's what defines an inequality, right? Solutions must be at least in the shaded region. So a good point would be 0, 0, 1, 3. Okay. So those are good solutions there. Next question. Again, same equation. Graphing inequalities leave regions of the plane shaded, but in this case, the inequality is y is greater than x over 2 minus 2. All the points that make this inequality true lie within the shaded region. So that's a big definition there. All the points that make this inequality true lie within the shaded region because of this inequality. So now you can move this point. So guys, tell me, where can I move this point? Where should I move this point to make it a solution? Here we go. 0, the best I can, 0, 0. There we go. There's 0, 0. That's a good solution. How about if I moved it up here to, look at this, it's almost at 2, 3. There it is. It's 2, 3. That's another solution. See that? Here's a quick test, guys. How about if I moved it right here? Right here at 4, 0. Is this a solution?
No.
No. Why? Because where is it? Dash. Thank you very much, Damien. This is not a solution, even though it looks like it's in the shaded region, which it is, but it's on top of the dashed line. So this is not a solution. So remember, this is kind of a little like clue right there, little hint about this. So anywhere inside here, see this? Anywhere inside here is a solution. All right, next problem. Now we're doing systems of solutions. Right now, the blue point in the graph is not a solution to the system because obviously it's outside. It's right here. So in order for it to be a solution to the system inequalities, it has to satisfy both inequalities. So that means I can't move it here, and I can't move it there. So we have to move this where the shading comes together. So guys, give me a point where the shading comes together that can make this a solution. Mm-hmm. Can somebody else tell me, like a new person, tell me where should I move this point to make this a solution of both equations? Bailey did one before. Can someone else tell me where I should move this? You guys can do this. You guys should have your own opened up so you guys move it. What do you think, Damon? Where can I move this point?
Honestly,
Just we're learning, right? So let's try this out. Where can I move this point?
I mean, I'm guessing the system is not an equation, but I'm guessing maybe 0.857, 3.5 571. It's
So,
right on the solid line right where the two meet.
like right here, you mean?
Yeah, that would work too. I didn't think about that. My fault.
Okay, that's fine. How about any other easier points we can go? So right here, 1.35 comma 5, that's 1 point. Can anyone tell me another point I can move it to? Five. Let's see it. Yep. Thank you, Adriana. That's it. 5. Notice the shaded region right here that mixes the blue and the red together. Perfect. Perfect. Now the good thing about it is I can even move it right here. And this is like a 2.7, kind of like a 2.7 right here. And that's still a correct solution point. Okay, because this is on a solid line and within the two shaded regions. So obviously anywhere in the combined shaded region is fine. Look at that. All right here. All moving around. Perfect. All right, next question. Solution of the system. Oh, it's funny. I just moved it at 2.7. Here it is. Joseph moved the point to 2.7 in his point, a solution to the system of inequalities. Is it a solution? Yes or no? I should see a lot of people telling me the answer right away. Is this a solution? Yes or no? Yes, it is. Explain your thinking. So this is your part. You explain why this is a solution. And here's the hint. It's on what? A solid line, and think about how to put it together with the shaded region. Okay? Okay, next question, last one. Which graph correctly displays the inequality? Okay, so this is some advanced thinking now for what we've done so far. So guess what we can do? We can graph this equation, open up Desmos in a separate page and graph these and see which graph matches it. Number two, we can start taking a look at the slopes and the y-intercepts and see where they cross. Okay, so you know that this is y less than negative 2x minus 3. So it crosses the y-axis at negative 3 right here. So where is negative 3? So if I take a look at it, these are all increments. This is from negative 10 to 10, all of them, both ways, from left to right and up and down. So if I want to take a look at it, negative 3 is crossing it right here every single time, right? So we know that much. Second, it is y less than. So that means it has to be a dashed line. So you notice I have two dashed lines here, right? But these are not dashed where they're crossing the y-axis. For the second equation, it says y is greater than or equal to 1/3 x plus 2. So it has to be greater than, it means above the graph, which is these two, but it has to be a solid line. So again, use your knowledge, okay, what we just learned and review together and pick the right one. So I'm going to go ahead and stop record.